Today's topic is a discussion of gas-fired kilns.
Welcome to the Potter's Roundtable, a monthly podcast where we share our passion for the ceramic arts and a collection of topics specific to potters. Remember to subscribe so you don't miss a single episode. Enjoy the show.
So that's the hardware for propane. For natural gas, it's a little different. So for natural gas, first of all, I have a gas meter. I'm just going to sketch these in quickly and then I'll talk through it. Okay, so this is my gas meter coming into my house. And the meter actually does two things. It regulates the pressure and it also records how much I'm using. And this is what when they come to read your gas meter, they send you a bill. This is what, typically it has some kind of a dial or a gauge on it, and it's reading cubic feet or something of gas that you've used. So this is your gas meter, and then coming right next to it, coming out of your gas meter, you'll have the main shutoff for your house, basically a safety valve. You can come, and it's usually right outside, right next to it. You can shut everything. You can shut the whole supply to the house. So then this is the line going into your house, and I've drawn it here purposely much fatter. Because even on a normal house, this might be a 2-inch pipe, big pipe. And then this is a basso. So now I've got it set up for a kiln. This is a basso valve again. And I've got the same idea. I've got a only a pilot burner here. Now this is a blower, because that's another important point is I can't use a Venturi burner with natural gas because I don't have enough pressure to make the suction work. That only works because I've got this jet of high pressure gas shooting through the burner, creating the suction. Well, with natural gas, it's more like kind of a leisurely flow. Not quite, but I don't have enough to really operate it. So I basically have to use a forced air burner. So I've got a forced air burner. So I got my gas line coming out of the basso with a shutoff valve or a regulating valve, and then it sticks into the air supply on the burner. And I still have my pilot light, and I still have my thermocouple going to the burner. But again, this is my flow valve for my pilot light to adjust the flame on my pilot, and this is my control valve for the burner. So now if I'm firing this on a gas kiln, this is my valve that tells me how much gas I have, and then I can open vents or regulate the speed of the fan to regulate the air. So these are my two controls for firing this. The power control for the fan. And on some of these fans and blowers, there are like little vanes you can open it up and close to let different amounts of air into the fan. And others you can control. In some cases, you also control the speed of the fan. So these are my two controls, my air supply and my gas supply mixed into the burner. So as I mentioned, with natural gas, I need forced air burners because basically the low pressure of the natural gas just can't operate a Venturi burner. So I can't, and also with natural gas, I can't vary the pressure. I don't have that option anymore because that's determined. They're not going to let me have high pressure in my house. That's my 7 inches of water column on my quarter PSI. So I don't have pressure as something I can adjust anymore. All I've got is amount of gas at whatever the pressure they're giving me. Along with these lines, where the gas enters the burner here, or in this case, inside here where the gas pipes in, there's a thing called an orifice, which is finally the actual hole in the pipe that the gas comes out of. And they're surprisingly small. I mean, in a burner this size, the orifice wouldn't even be quite as thick as a pencil lead because the gas is under pressure. There's a tremendous amount of gas coming out, even that little hole. But in general, the orifice for natural gas is much larger than for propane because, again, it's not as much pressure and there's not as much fuel value in the natural gas, so I need a bigger hole. And this comes into play where you might get a burner that is set up for natural gas, and let's say you buy a used burner and you want to convert it to propane, you have to change the orifice size because the orifice size for natural gas is way too big for propane. keeping it because the gases are so different and you're using them under different conditions. So the amount of heat produced from a burner depends on basically on the amount of gas being burned, and the amount of gas is determined by the pressure and the size of the opening or the size of the pipe. So heating is controlled by controlling the gas pressure with a regulator, if you have propane, and varying the gas flow, and that's the size of the opening in the pipe, generally with a ball valve. And the ball valve is nice because it gives you pretty precise control by varying the size of that opening. When the ball rotates and the hole in it and the two holes line up, you can get pretty precise control of the amount of gas going through. And as I say, personally speaking, I found the best procedure for gas kilns is set the pressure and then just work with the flow. And if I have to later on, I might increase the pressure again, but don't constantly vary the pressure at the same time. Set the pressure, and you find out this with experience, like for the burners. What's a certain pressure I need to make this burner operate? And it might be, let's say, 10 psi. So I set it at 10 psi, and then for almost all or most of the firing, I just open the flow valve, basically, like the throttle. And I just open it up and give it more and more and more gas. Okay, so then I want to talk just some general gas kiln design features. This is sort of, as I say, this whole talk is meant to be an overview because we can't go into too much detail, but a couple of things. In terms of the kiln designs now, basically for gas kilns, we're using the same designs that have already been established and are used for wood. So we've got updraft, crossdraft, and downdraft in terms of the flame path. Now this is something where generally, at least nowadays, most people that are firing wood kilns, they're not doing updraft wood kilns. I mean, the old primitive kilns, essentially, we talked about before when we talked about the history of wood kilns, were essentially updraft, where you had a circular enclosure and the fire on the bottom, and you stacked the pots on top and the flame came out the top. That was an updraft. But people nowadays, at least with more contemporary designs, they're not firing updrafts. But they are firing downdrafts and crossdrafts. But now with gas designs, we can have an updraft. And a matter of fact, this little commercial kiln I have out there, it's an Olympic. It essentially is looks like an electric kiln body. And the burners are on the bottom, and I stack the work in there so the flame comes in the bottom, rises up past and through the work, and exits the top. So I can have all three now with gas flow paths. I can have updraft, crossdraft, and downdraft. In general, gas kilns are single chambers. We're not talking about moving a fire down, moving a fire along from chamber to chamber like you do with multi-chamber wood kilns. So they're almost always single chamber kilns. But again, they can be arch designed, so you can have a catenary arch or a sprung arch, or they can be flat top. But they're basically all single chambers because I'm not worried about moving the fire. And another important design feature is that with Venturi burners, I need to have inlets into the kiln for additional air. The air that the burner pulls in by itself is not enough to get complete combustion of all the gas. So I need what this air, by the way, that's coming into the burner is called primary air. It's the air that's mixing immediately with the fuel. But that's not enough air to completely burn all the fuel. So I need additional air. That additional air is called secondary air. So that when I set up this burner on a kiln, I have air coming into the burner through here, and I also leave a space around the burner head where it goes into the kiln, where additional air can be drawn in and mixed with the gas. That's the secondary air. And so with a Venturi burner, I need secondary air. So I need a space or a place around the burners for air to be able to get in. I don't just seal that burner head up tight to the kiln. And then if I need secondary air, I need some way to pull it in, so I need a chimney. And what happens is the chimney, it's the same function as the fireplace. The exhaust gases from the kiln are going up the chimney, and they create a draft, and they pull in the secondary air that I need to burn with all the gas. So for cross-draft and downdraft kilns, I need a chimney. For an updraft kiln, I don't, because the kiln itself is functioning like a chimney. Another feature also with Venturi burners is that, as I mentioned this before, it's important to get thorough mixing of all the gas and the air before the wear chamber as much as possible, because I don't want unburned fuel or air hitting the pots. I'd like just the flame and the hot gas is hitting the pots. So I need some way to design the kiln or set up the kiln so that I get complete mixing. Because the air that's coming into the burner, I'm getting pretty good mixing. But the secondary air, I've got a stream of gas and air, and coming around the outside of it, I've got air. So there are features you can build into a kiln that will help do that. One of them is a bag wall, which is a wall that separates where the gases are coming in from the wear chamber. And you might even purposely, for instance, point the burners at the bag wall, which means the gases are blasting on this wall, and it creates turbulence and tends to mix the gas and the air. Or I can have a separate little space that the burner blasts into, and it gives a chance for the gas and the air to mix before it actually hits the pot. So for example, if I had a Catenary arch kiln, looking at a Catenary arch kiln like this, my wear might be stacked here. And let's say this is a burner port going in. I might have a wall here, so there'd be a channel down the side where the burner would be blasting this way, and the gas and the air would have a chance to mix before it climbed over the wall and hit the wear. So I'm not pointing the burner directly at and the air also directly at the wear. If I look at it from the top, it would look like this. Here's my wear, Here's my wear stacked in here. And my burner is blasting down this channel this way. So this is essentially a combustion chamber, a space where the gas and the air can burn before it actually comes in contact with the pots. So it allows more time and more space for the gas and the air to mix thoroughly before they actually hit the pots. And part of that is because I don't want air hitting on my pots, but I get the most efficient heating. I don't want the gas and the air to mix, for instance, in the chimney, but to go all the way through the kiln, because then I'm getting the most efficient heating in the chimney. So I want the gas and the air to mix as soon as they come into the kiln to get the most efficient burning, so that the heat is where I want it to be in the kiln, not later on. Years ago, we had a little kiln at one of the locations, one of the studios where I worked, and the kiln was so small, and the way it was designed was, we were getting the most efficient heating in the chimney. And so I had raw gas going through the kiln, some of it was burning, and I had air going through the kiln, and they finally mixed really nicely in the chimney. And so the kiln never quite got hot. The chimney got really hot, but the kiln never quite would reach temperature, because the most efficient burning wasn't happening in the kiln, it was happening after it got through the kiln, by the time the gases and air had a chance to mix.
Why was that?
It was a bad design on the kiln. It was a homemade kiln, and they didn't design it properly with a small kiln. And so what I did was, to help fix it, I put a tunnel, and I backed the burners out from the kiln, and I made about a 2-foot long tunnel. And I put the burner at the end of the tunnel, so that I had this 2-foot tunnel before it even got into the kiln. And that was, because this was a really tiny, the chamber was only about this big. So the flame and everything would go right through it. So I backed the burners basically further out, and I put obstacles like kiln posts inside there. So the flame had to go around them, and it gave a chance for the gas and the air to mix. So that now I moved the best burning back toward the burners by moving the burners back 2 feet.
We hope you're enjoying the show. Please take a moment to leave a 5-star review on your podcast platform of choice. It really helps new listeners find the show. Don't forget to subscribe to receive updates as new episodes are released. And if you'd like to support the video and podcast production of the Potter's Roundtable, become a patron. Go to patreon.com and search for the Potter's Roundtable. Your support will help us achieve our goal of creating a digital library spanning the ceramic arts for use by educators and artists alike. Thank you for your support. Now let's get back to the show.
So I mentioned, with a Venturi burner, I need a chimney to pull in the air with a cross draft and a down draft. I don't need a chimney for an updraft kiln or with a forced air burner. And for instance, if I have a forced air burner kiln outside, then I don't even need a pipe, because they can just come out the top of the kiln. But in a building, then I need some way to get the exhaust out of the building. But I don't need it for draw. But I do need, and so now if I'm using a chimney and I'm pulling in secondary air, I need some way to control the draft, right? I need some way to control that suction. That's what the damper is for. So I need a damper in the chimney to be able to regulate the suction that the chimney is creating. Like how can I control the amount of secondary air that's being pulled into the kiln by the chimney? That's done with a damper. So if I close the damper more, I cut down the draw of the chimney and I reduce the amount of air, the secondary air that's being pulled into the kiln. Everybody follow that? So that's what the damper is doing. And there are two kinds of dampers actually that are used on kilns. One's called an active and the other is called a passive damper. And an active damper is the kind you're familiar with, where generally you have a sliding plate of some kind that you push into the chimney opening and it partially closes or completely closes when you're done, the opening in the chimney. But a passive damper is if you have, and we have, for instance, over at Hood College, we have incredibly tall chimneys on the kilns, taller than they need to be, because when the kiln building was designed, it had a very high roof for safety reasons, but then the chimneys had to go all the way up through the roof to clear the roof. But the chimneys were actually a lot taller than they needed to be for those kilns. So we had to have a damper. So what we also put in is what are called passive dampers. These are holes in the chimney that you can open up to bleed off some of the suction. And it works the same way. If you've ever noticed, you have a vacuum cleaner. Most vacuum cleaners have an adjustment on the handle. There's a little thing you can open so that when you want to vacuum your drapes, you don't suck your drapes into the vacuum. You can decrease the suction by opening that hole and it bleeds off some of the suction. Works the same way. If I pull out, these are holes in the chimney above the kiln body. So if I pull out a brick and the chimney is pulling, it'll pull air in from that hole before it pulls in any air through the kiln. So I can weaken the draw of the chimney by opening these passive dampers. And they're passive because I'm not sliding anything, I'm just opening it up. It's a hole, basically. So I put in passive dampers in the chimney, and if I have a really tall chimney, I can cut down the draw to a reasonable level and then still control it with an active damper. Because one of the problems we had at Hood, and in other places as well, is that if the draw is so strong, then the active damper becomes incredibly sensitive. You can't get good control because it's so powerful. So if you cut the draw down with a passive damper to a working range, and then you get much better sensitivity on the active damper. In terms of you move it a little bit, you can see the change. Okay, guidelines. Some guidelines for operating for constructing a gas kiln. Well, first of all, for propane, you really need oversized gas tanks. You need gas tanks bigger than you think you're going to need because, as I mentioned before, in cold weather, the pressure is going to drop. So as the temperature drops, the pressure can drop considerably. The other thing is with propane, you can't run the tanks to empty. It isn't like you can use all the propane in the tank because when the propane level gets low, the pressure drops enough that you can't run your burners again anyway. So you generally don't, in a rough sense, you generally don't run the tanks lower than 50% anyway, because you simply can't get enough, you can't generate enough pressure. So it isn't like you can think, well, this will be enough gas. It isn't like a barbecue tank where you run it until it's dry. In this case, because I might need higher pressure, I always have to have some reserved liquid propane in the tank. So I generally need bigger ones than you would think you do. For a gas kiln, in terms of like construction, you need high temperature bricks, but you generally don't need super duty bricks. You don't, because you're not worried now about slag resistance. Like with a wood kiln, you're worried about ash corroding the bricks or ash eating into the bricks and slag eating bricks. You don't have that problem with gas kiln. So you don't need the best quality super duty bricks or resistant bricks. You can get away with just based on temperature, just high temperature bricks. One other thing I just wanted to mention, refractory bricks are rated by what they call a K rating. A K rating. And this means that bricks are given a number, like a brick might be called a K23 brick. And what that means is that brick is designed for use for continuous operation at 2300 degrees Fahrenheit. And bricks come in all different ratings, K18, K23, K22, K26, all different ratings, and depending on what they're used for. So for constructing for a gas kiln, you might want to have, for instance, at the hottest part of the kiln, let's say K26s, which is 2600, which is a little, higher than cone 10, but it's a safety margin. And then in other parts of the kiln, you could drop down to K23s, for example. But you don't have to worry about slag resistance and ash resistance like you do as much with a wood kiln. When you're building, or if you're designing or planning a gas kiln, as with any kind of kiln, you design from the inside out. You think about what shelf size are you going to use, how are you going to arrange the shelves, and then you work out. You say, okay, if that's going to be the space that my shelves are going to occupy, what additional space, now with a gas kiln, what additional space do I need around those shelves to provide for the gas to burn? Maybe I want these combustion chambers. So how much additional space do I need for the gas around that? And then where do my walls go? Where do my walls start? So it's pretty much standard practice when you're building a kiln to design from the inside out. What you think about, let's say it's your own kiln, what size work am I going to make, and therefore what kind of shelves, how big shelves do I, am I going to make large work, mostly small work, mostly short work, whatever. What size work am I going to make? Therefore, what's a practical shelf size? How many shelves do I need? How much work am I going to be making? And you think outward from the inside of the kiln. And as I mentioned, if you're going to be using Venturi burners, when you're designing the kiln, you want to provide or allow extra space for the gas to burn, a combustion chamber, a combustion space, outside of the wear chamber, outside of where the work is actually stacked. It's also important, another consideration is the height of the chimney. The chimney has to be, and this depends on the kiln design and the size, the chimney has to be tall enough to create enough draft to pull in enough secondary air to work with the burners that you're going to use. So there are some basic calculations you can do, and there are some good examples, for instance, in Olson's kiln book. They give you some rules of thumb that you can use for, depending on the flow path, how high should the chimney be, for instance, relative to the size of the construction of the kiln to give you enough draft. Because, for instance, different kiln designs require taller or shorter chimneys. A downdraft kiln, where the flame is coming in and going up to the top and then being pulled back down to the bottom, requires generally a taller chimney than a cross draft, because I'm having to pull that flame back down to get it to go out. And an updraft, of course, requires no chimney. So just depending on the design of the kiln, as well as the size, affects the height of the chimney that I need. Okay? And you also have to think about the cross-section of the chimney. How big a hole do I need in the chimney? Well, one of the guidelines for that is, if I have burners going into a chimney, I at least need the cross-section of the chimney, the hole in the chimney, to be the same as the total area of the burner ports. If you think about it, if I'm putting gas in, I have to provide enough space for that same gas to get out. So as a minimum, the cross-section of the chimney should be at least the same area as the sum of all the burner ports. Whatever the area is of all the holes going in, that same area should exist in the single hole of the chimney. And it doesn't hurt. Plus, I found when I built kilns, I make everything oversized because I can always cut it down. I can't increase the size later. If my flue hole in my chimney is too small, I'm done. I can't do anything about it. I can always put a damper in and cut down the draw, but I can't make it bigger later on. So to me, I found it always go oversized, because I can always plug up holes. I can't add ones later on. So, and this is one of the problems that people run into with gas kilns, with, let's say, Venturi burners. We'll talk a little bit about it, but if they can't quite reach temperature because they can't draw in enough secondary air to burn enough gas to get the temperature to get to the final point. And the whole thing, in that case, might be just the chimney. They simply can't pull in enough air to burn enough gas fast enough to get the temperature high.
So the answer to that is make the chimney taller?
Well, not make the chimney either taller or bigger. It might be the fact that the hole is too restricted, and they simply, unless you made it hugely bigger, you simply can't draw enough air in. So some general operating principles, some general comments. As I say, this is what I generally do is before the firing, I set the burner air, this right here, this air adjustment on the burner, I almost never play with that. because that's another control that you can drive yourself crazy with. So this control, this disc on the back of the air, I set that air to give me the maximum efficiency of the burner, and then I almost never touch it again. Because and it's not necessarily wide open, because if you put in unnecessary, more air than I need, more air, I'm wasting fuel actually, because I have to heat up the air for the kiln to get hot. So it takes energy to heat up that extra air if that air isn't doing it, if I don't need it. So there's an optimum, at a normal pressure range, there's sort of an optimum setting for this air to make this burner operate the most efficiently. So what I generally do is I set that at the beginning, or I know what it is for that burner, and I never touch it again. So that's one less. There are a lot of knobs I can turn on the kiln, but it'll drive yourself crazy if you try to adjust them all in the middle of a firing. The only time I might adjust this would be if I'm doing, let's say, is everybody familiar with like carbon trapping glazes? You're purposely trying to make soot in a firing. The only time I might adjust this would be if I was trying to purposely make soot in the kiln for a carbon trapping glaze, and I really cut the air down so that I get a really sooty flame. But other than that, I don't touch this. I just I set these to what they're efficiently, and I leave it like that for the whole firing. And I've been at firings again where people are playing with these to try to do something. And yeah, you can make a change, but you can't keep track of 3 or 4 or 5 or 6 different things and in terms of, of trying to solve a problem. The fewer controls you have, the fewer things you do, the easier it's going to be to solve the problem. So when I'm firing the kiln, I'm using the gas flow valve and I'm using the damper. That's it. Too much gas, and actually you can go, I mentioned like too much air is a problem because, for several reasons, it wastes fuel because I still have to get that air hot in order to get the kiln hot. So I'm burning fuel to heat the air, and the air isn't doing anything. I also, is everybody familiar with the idea of reduction? What we're talking about reduction firing. So if I have too much air, I'm also messing up my reduction. I can't maintain reduction. And so too much air is a problem, but also too much gas is a problem. If I'm putting in too much gas and I'm not burning it efficiently, I'm wasting gas. And so it's possible to be doing a firing and the kiln, the temperature isn't rising fast enough, and I solve the problem by turning down the gas. Because I've got too much gas going in there. I'm not burning it, but I still have to heat up the gas, because it would be the same as pumping cold air in there. So I actually solved the problem by turning down the gas a little bit, and now I'm back down to the point where I'm efficiently burning the gas, and I'm getting the most heat out of it, and then the temperature goes up. So I can have a problem with too much gas, or too little gas, or too much air, or too little air. So the idea is, the trick is to get the right balance. And as I mentioned before, I found it's really important. Change only one thing at a time. This is one of the things actually I like about gas kilns, is make a change, wait 5 or 10 minutes for the new conditions to adjust in the kiln, and see what happens. For instance, if you're looking at temperature rise or waiting to see what happens, the nice thing about it is on a long firing, like a 3, 4, 5, 6, 7, 8 hour firing, you can't do any harm with a quick 10-minute change. You can't hurt. If you make a change and it either goes the wrong way or nothing happens, put it back where it was, and chances are you haven't hurt a thing, because it's a long firing. So it's not responding instantaneously. The wear is not responding to instantaneous changes like that. So this is a nice thing, even when you're learning to fire a gas kiln. Change one thing and look at it and see what happens. And is it going, like all of a sudden, as the temperature starting to climb again, that's what you wanted? Okay, then you're on the right track. If not, put it back where it was, change something else. And you're not really going to mess something up in terms of the work by making those short changes, because it's a long enough firing that it sort of averages out. Keep in mind, to keep the temperature rising, we have to keep burning an increasing amount of gas. As the temperature is going up, I have to keep increasing the amount of gas that I'm burning, because I'm losing, as the temperature is going up, I'm losing heat faster. So as I say, it's like running up a hill, only as you're running up the hill is getting steeper and steeper and steeper, and I have to work harder and harder and harder to keep going up the hill. But as I mentioned, firings don't necessarily have to be long. Like our little Olympic kiln out here is 5.5 hours. And I get nice cone 10, cone 11, good reduction. And it's a small kiln, but that's the advantage of it. It's Sure, it's fast. Yeah, I just loaded. It's loaded, ready for another firing. And the other thing just to remember is, of course, just like any wood kiln also, is at the end of the firing, close up the kiln really tight, which generally means, for instance, pull your burners back and block your burner ports, because the chimney is going to continue to pull, and even if you put in the damper, unless you've got a really good damper, it's still going to tend to, as the kiln cools down and the gas is cool, they're going to contract. They're going to tend to pull in air. So you want to seal the kiln up tight, and that means like putting a plate in front of block the burner ports, so you're not going to draw in more air at the end of the firing. We know that this was a lot of information in a short period of time, so if you want to hear it again, listen to our podcast version of the presentation. Search for the Potter's Roundtable on your favorite podcast platform.
The Potter's Roundtable is brought to you by Washington Street Studios and our patrons. If you enjoy the show, please subscribe, give us a 5-star review, and tell your friends. If you want to learn more about Washington Street Studios and shared studio memberships, please visit our website at www.hfclay.com. Thank you, and we'll see you again next time on the Potter's Roundtable.